Good morning, everyone. Welcome to the world of C programming. In this session, let us learn basic structure of C program, variables, logical errors, syntax errors, and so on. Before jumping into the C programming, let us learn basic terminologies and features of what are the different features of C language. So I can say what is a program? A program is nothing but a set of instructions that are executed to perform a particular task. In this sense, I can simply give you an example like you want to go to college. Okay, so what are the basic steps you will follow if you want to go to college? You will pack your bag is the first step, and later on you will step into the college bus, and later on you will get into the college. So these are three basic set of instructions you will follow to go to college. So now in your computer, if you give set of instructions to do a particular task to the computer is nothing but a program. So simply giving set of instructions to do a particular task is nothing but a program. So again, what is a programming language? Set of programs that are given to a computer by following the syntaxes of the particular language is nothing but a programming language. That means set of programs to design a software is nothing but a programming language. So when you are following a programming language, you have to make sure that the syntaxes of the particular language are you are familiar with those syntaxes of that particular language. Now we will see what are the various like features of your C language. So it is simple and efficient. It is like you can know the syntax. It is easy to learn the syntax of C language, and it is also known as parent of all remaining programming languages. And next, the next feature is speed. When you see with the compare with the remaining languages like Java, Python, right? Remaining programming languages like Java and Python. So your C is compiler executed language. So the speed will be more efficient when you compare with Java and Python and remaining all languages. C is much speed. Okay, so next, modularity and structured language. The third feature is modularity and or structured structured language. So what is modularity? In the sense, modularity means dividing into small functions or module. For suppose if you take, if you are having 100 line of statements of a program, okay, it is very complicated to write like if you want to find the errors in 100 line of statements, it is much like I can say, to find the syntax errors or logical errors, you may find difficulty to find the errors in the massive programs. Okay, so what I will do is it will be easier if I divide the each task into different modules, so that the efficiency will be more and you can reuse those functions or modules again and again. This specific feature is nothing but modularity or structured language. Okay, while writing the massive programs, when you divide the programs into smaller units like functions or structures, it will be more efficient for you to find out the logical errors, or else reusability will also be there, reusing of functions will also be there. That is nothing but modularity. Okay, and next, portability. If you see the feature, portability means if a like in this laptop I'm just executing a C program, and I will take this exe file and I will execute the same file in I can execute the same file in another uh, computer or desktop also. Okay, the next feature is existence of libraries. Existence, the C is a collection of vast collection of libraries, so that we can use many predefined functions thoroughly and easily. So, and then the next is popularity. So C is very much widely used in like embedded systems, operating systems. So it is widely used language and a popular language. And when coming to the next feature, dynamism. So dynamism is nothing but like operating the memory dynamically with some predefined functions like malloc, calloc. So you can dynamically allocate memory, you can dynamically free memory, in the sense you can operate computer memory also with the help of C programs. And next, the last feature is case sensitive. Case sensitive in the sense, if I give int some capital X or small x, the both will be different. The like ASCII codes of both the capital X and small x will be surely different, and they are given different values. Like ASCII values will be different for both the capital X and small x, and so they are treated different values itself. And that is the case sensitive is the last feature of your C language. Okay, next, jumping into the structure of C program. So here is the basic structure of a C program. So first, initially you have to write, while writing a C program, initially you have to declare the preprocessor commands. Let us see what are all the various preprocessor commands you are having. So when you are giving the preprocessor commands, initially you have to give the hash symbol. So if the compiler, by checking the hash symbol, by encountering the hash symbol, it understands that you are giving some preprocessor commands. So what I can say hash include include stdio.h. So this stdio.h is the header file. It stands for .h. H stands for these are header files. H indicates these are header files. And stdio is nothing but standard input output. So what happens when the compiler encounters this line of statement? When compiler encounters this line of statement, what it does, it adds these particular header files into your C program. I have written a C program, so I want to use some predefined functions in my C program. So what are the predefined functions that are stored in your stdio.h? Printf is one of the predefined function. Scanf is one of the predefined function. So these two predefined functions will be added to your program. If you are not adding these predefined functions, means you have to write for every printing. Printf means or printing to the output screen. For this printing output screen also, you have to write another massive program every time. So by including this predefined functions, you can easily and thoroughly use these functions without writing massive codes. Okay, so the next available predefined function is some include hash include. It is math.h. So if I want to use some square root or power or something else, I have to define this math.h predefined function. So by defining math.h, the inbuilt these all predefined, plenty of predefined functions will be there. So you can easily, efficiently use these predefined functions in your program by simply including this preprocessor directive. Okay, so another preprocessor directive is hash include. It is string.h. For using string functions, you can use all the string related functions in your C program easily. So these string.h functions, what are the various available string functions, will be learned in the later classes. Now, as of now, let us see with the std. Let us go with the stdio.h itself. Okay, so the next line of statement you will see is, this is the main. So main is the next line. So I can give int main within the open parenthesis and a closed parenthesis. So this is the return type. Int is the shortcut of integer. So here int is your keyword. By giving int means This is the return type. So what the function must return, right? While you are writing some program, it must return something, right? So what is the function returning? Whether it is returning the integer value, whether it is returning the character value, or when it is returning none, you will give void. As of now, I am giving my function return type as integer. Okay, so this integer, like this main function, will return integer data. Okay, so when if your compiler encounters this main, so it understood that this is the starting point of your function. How much the massive code there will be, but it checks for the main itself. In your program, how much massive code there must be, but there must be only one main function, and the whole program, the compilation starts with the main itself. Okay, you might be having many n number of functions, but you must have only one main function, and the compiler starts its execution from main function itself. Okay, so now after main, curly braces. Okay, for every opening curly brace there must be a pair of curly brace closing pair. Okay, so in that you will declare a variable. So after writing the main function, variable declaration must be done. I'll just, after this topic, I'll say what is a variable, what is the specifications, what are the uses for declaring the variable. All these things we will see just later. Okay. So after variables declaration, you will give some set of instructions to perform. Set of instructions to perform. After that, you will write a return statement so that return 0. So as you have given integer here, it indicates that the return, it understood that it has to return the integer value, and this is the exit of the statement. This is the completion of the program. The compiler understood this completion of the program. So when you start compiling from main, one line after another line, line by line, the execution will be done. Okay, so I can show you example of writing a hello world program. So what is the first line of statement we are going to write? It is the preprocessor directive, and it is hash include stdio.h, right? Next, I am writing int main opening and closing parenthesis. Okay, next curly braces. For every opening pair there must be a closing pair, it is must. And then I just want to write the hello world program. So all of a sudden, if you open the program, you have to know what is the program going on. The user must know, and the developer must also know. So I can give s double slash comments. So comments are nothing but some dummy line of statement. The user understands that what is going on here in the program, or the developer or the programmer, you must know what the program is all about. So I can call these as double, and for the single line of statements comments, I'll give double slash. So program for hello world. Hello world. Okay. So now I'll write just a printf statement. Okay. So hello Sri Devi. Okay. And now I'm ending my statement with a semicolon. So it indicates every C program statements in C program must end with a semicolon. It is must. The C line statements must end with a semicolon. Other than these predefined main functions, other than some uh, functions, other than some functions, every C statement must end with a semicolon. So here I am giving return 0. Okay, let us run this program. Yeah, after you'll just see at the downwards, if you run here, The compiling is going on there. So here, hello Sridevi, at the bottom of the screen you can see hello Sridevi Women's College. Okay, so this indicates your printf statement. You have to give whatever you want to write on the output screen. Whatever you wish to see onto the output screen is must be there within the double quotes in the printf statement. In the printf statements you must give these things in the double quotes itself, then only it works. Okay, if you see here, it is hello Sridevi Women's Engineering College. Okay, so let us jump to the next topic. Here I have given just a simple hello world program and then the variables. Okay, when coming to the variables, you just assume before going to learn detail about variables, you just assume that you are holding a glass into your hands. You're holding a glass. So what is the glass? Glass is some container, right? So it stores some liquids or solids, whatever it may be. The container holds some uh, contents, right? So likewise, variables are also names that store some data. Here in our programming, variables store some data. So you can say glass is name of a variable, name of variable, and later on value like I am storing just water. You assume I'm storing water in glass. So here in our computer language, what we store data, that is nothing but some values. Okay, so here glass is the name of a variable here. So how to define a variable, I'll just tell you in a little span of time. So here glass is the name of a variable which I will give, the user or the programmer will give, and the water is nothing but the data or values which you want to store. Okay, and likewise if you want to store liquids or store solids also, like, so likewise if you want to store integer values, int keyword will be used, and if you want to store character values, you will give char, and if you want to go for floating values, you will go for float data type. So let us see within a short span of time all these things. So by definition, I can say a variable is nothing but a name given to a storage area that our programs can manipulate. Okay, so a variable is composed of letters, digits, and the underscore characters. Okay, so uppercase and lowercase variable names also given, but if you let me show you the syntax first. So return type, sorry, data type, it is the variable name, and you can give value here itself. You can give value it's here itself. So data type means like what type of data I have to store. First, suppose if I want to store just numbers, like numbers, how many subjects you are having. For suppose you are having 6 subjects, right? So it is an integer value. So with the help of the int, it is one data type. So with the help of the int, so I just want to store your subject. Subject is a variable name. So how many subjects you are having? For suppose you are having 4 subjects. Okay, so I have given here. So subject is the variable name. Okay, and you are storing 4 in the subject. Okay, so in the memory what happens, I'll just show you. Okay, suppose this is my memory, assume this is the memory. So every location in the memory is having address. Likewise our houses, whatever, colleges, it will be having some address. So likewise in the memory also, address will be there for every particular location. Address, suppose at the location 2000, I'm just storing the value 4. Okay, so here I'll just give the okay. So here and the variable name is, I can write as, it is subject. Okay. Variable name is subject. So here this is the 2000. So I will declare another variable. I can declare in a new line of statement, or else I can declare here also. So I'm just declaring your marks. So so marks I can give as float data type, because you are having like a float marks. Why? Because I'm giving float. So marks you will be getting some 85.5. The marks it will be of floating points, right? After this, after decimal, you are having the values still marks, right? So that's why I'll just give float marks. Okay. So at the location 2004, I'm just giving the marks. So what is the marks? I can give simply 85.5, right? So in the memory what it stores, 85.5, right? So for each and every one variable we can store only one value. Okay. Initially this is the basic thing, like for one variable you can store one value. So what is this? Here I have given 2004 address, and here I have given 2000 address, and here I have given 2004 address, right? So what is the difference? As I have given here integer occupies 4 bytes. Okay. And your float occupies 4 bytes. And when coming to your character, if I give char c equals to, when you are assigning a value you have to give in a single quotes. Okay. So here char, it is 2005, the value is r. Okay. So here I have declared three different data types, three different variables. So here finally variable is nothing but a storage space which stores some data. Okay. So later on I have declaring initializing. Initializing also done here. I have initialized the value. Initializing means assigning some value. Okay. You do this thing. I'll assign some task for you. So likewise, I'm assigning some, allocating some value, giving some value to this variable, and this value is storing into the memory. Okay. So here at the time of declaration, this is I'm declaring a variable, declaring a variable that I will use this variable in future in my program further. So this is declaration of a variable. While I am using this variable, so print, I'll just ask the compiler, so print the marks. Okay. So what happens, at the time of definition, I'm defining definition, the memory will be allocated. Major of the scenarios, at the time of declaration, the memory will not be allocated. At the time of definition only, the memory will be allocated. Okay. So this is the initialization. Here we can see memory space is not allocated for a variable while declaration. It happens only at definition. Definition in the sense, while we are using in further program, we will use that variable. So that uses of is nothing but the definition. Okay. So next, here is the some example I have shown, and like what happens, it allocates memory to the particular variable. Space once allocated whenever your program is started and never be freed. Okay. And it will not be freed automatically, manually, by using another memory allocation programs, memory allocation functions. So we must free them automatically. It will not be freed. Freed means nothing but emptied. Okay. So next coming, syntax and logical errors. I will show you syntax, what are the different types of syntax and logical errors we are having. Okay, going to the online C compiler. For suppose for writing the printf statement, for writing the C statement, we must give semicolon. I am not giving the semicolon here. That means I am violating the protocol of the printf statement, right? I am violating the syntax. I am violating the rule. I am violating the protocol for the C statement. Every C statement must end with a semicolon. This is the one of the protocol of writing a C program. But here I have violated the syntax. So this is nothing but syntax error, right? See here, if you see here in the main function, semicolon, expected semicolon. So this violating is nothing but the syntax errors. These errors regarding the protocols of the functions or else the protocols while using the predefined functions or keywords, whatever it is, you violate the rules while writing the program. It is called syntax errors. And now let us see what are logical errors. Okay, so what are different types of logical errors? For suppose I have given you a task. For suppose I said you to add two numbers, right? So what I will do, I'll take three variables. So for suppose I can say int a comma b comma sum, right? So I can initialize the value of a here only 9 and b also here only some 9 again. So this both the values must be added and these must be stored in the sum. So what is the like syntax of adding two numbers? Like sum equals to a plus b I have to give. Now by mistake I have given without knowing the task clearly, or by mistake I may give star. So my result is actually, what is the expected result? Expected result is 18, right? But the obtained result is 81. So is this the right one we are expecting from the computer? No, this is not we are expecting. We are expecting 18. These unexpected situations are called as logical errors. These are unexpected results regarding the logic. Okay, so these sort of errors are simply called as logical errors. Okay, so syntax errors are nothing but violating the rules. Okay, and the logical errors or bug, you can call them as bug or mistake in the program source code. Okay, in the program source code is nothing but the program we are writing is called as source code. Okay, it's something like high level language. We are writing in a English language, I can say it is in English language. This is called as source code. Okay, result in unexpected behavior. See here, I have to add two numbers, but by mistake I may type asterisk, or without knowing the task clearly, without knowing the expected result clearly, I have given star, asterisk. For multiplication you will give asterisk. So this will lead to the logical errors. So let us know quickly what is source code, object code and executable code. Okay, so source code is nothing but here I have wrote the program, right? So this is nothing but the source code. The program you are writing is called the source code. Then what is the object code? This source code is given to the compiler. Okay, so C compiler, we will give this source code to the C compiler. So what did this C compiler does? It just quickly converts this into the extended source code, and this generate an object file with, we will save our source code with I can give simply source code as SC. Okay, so my program name is hello world. Okay, I will give it with .c extension. Okay, when this source code is given to the compiler, it generates object code. Okay, so what, with what extension? Hello world dot obj. Okay, again this object file is given to the linker. This object file is given to the linker from the compiler. Linker will take this object code and generates hello world dot exe executable file. This is called executable file. So here, if you see here, with the .c extension, what you are having, you will call it as the source code. With .obj extension, it is the output of the compiler. You will give your C program to the compiler. Internally, it will happen. You will not physically give, but internally it will happen. The source code is given to the compiler. The compiler generates .obj file, and the obj file will generate is given to the linker, and it generates uh, .exe files. Pictorially, we can see here source code, compiler generates object file, and the linker and the executable file. So these are the runtime library files. So what are these runtime library files again? Okay, initially I said some .h files, right, header files. So these header files are having I can say printf we are writing, right? Some printf we are writing internally, some data we are writing in the printf. Whether we are writing this printf function according to the protocol or not will be checked by the compiler. And this printf is like the code regarding to the printf is given to the linker, and this will check by the, and here this will check by the runtime library files. Okay, so the linker.exe file will be generated from the linker.executable file will be generated. And here is, it is the one of the feature portability. This executable file we can execute somewhere else, some elsewhere in the other laptops or computers. Okay, so next we will see operators. What are the different operators we are all having? So operators. Okay, so what are the different types of operators? So before operators, let us see operands, operators, some basic terminologies. Like I want to add two numbers, so what I will give? A plus B. Okay, so here you will call A and B as operands. Okay, operands, and this is the operator, and this is the operator. Okay, and if I give something like this is called an expression, right? You are might be familiar with these things. This is an expression, and these are the operands, and this is the operator. So in C language you are having plenty of operators. So now let us see what are all the different operators we are having. Okay, so first arithmetic operators. Arithmetic operators are nothing but arithmetic operators. So what are all the arithmetic operators? Basic operators. Okay, so arithmetic operators are, I can say, plus, minus, divided by, multiplication, and the modulo operator is also called as, this is modulo operator. You will call here as modulo operator. That means reminder. Whatever the reminder you are getting, this is called modulo operator. So plus is for adding, and minus operator is for subtracting, and this slash operator is for dividing, and this asterisk operator is for multiplying, and this modulo operator is for the remainder. Okay, so these are all the basic these are called arithmetic operators and the basic operators also, arithmetic operators. So the next operators are relational operators. That means they are giving relation between two numbers, whether they are greater than or lesser than. Relational operators. So what are the relational operators? It is greater than, lesser than, some greater than or equals to, lesser than or equals to. So what are the available relational operators? Not equals to and double equals to. What double equals to do? Greater than, you know, right? With between two numbers or two different values, which one is greater, and the lesser, which one is lesser operator? Greater than or equals to, and this is lesser than or equals to. And now the new operator is double equals to. So what this double equals to? It is the comparison operator. Okay, if you go with single equals to, okay, it is called assignment operator. Single equals to is nothing but the assignment operator, right? If you go with single equal to, assignment operator. So what is assignment operator? A equal to B. If you give like this, means the value in B will store in A also. That means you are assigning the data in B to A. You are assigning the value in B to A also. Okay, so the right hand side operand value will be stored in the left hand side also. If I am having the value of 3 in B, after this line of statement, my A value will also be 3. So here single equals to is the assignment operator. Okay, and double equals to is the comparison operator, like equals to. Okay, to compare both, like A equals to B, you will give like this. Okay, whether both are equal or not. So for comparison, it is double equals to. For assignment, it is single equals to. Okay, and the next is greater than, not equals to. Okay, something here in the number, like you'll just hold one, and on the numbers key you just hold the shift and one, you will get the not equals to operator. Okay, so this is the not equals to operator, another relational operator. Next, logical operators. Okay, logical double ampersand, this is called double ampersand, and this is operator is ampersand, and double ampersand is like and, or, this is or, and this is not. Okay, so these are all the logical operators. That means when you are operating with different values, if both the values are 1 1 means you will get 1. If any one of the value is 0 means you will get 0. Okay, so or if any one of the value is 1 means you will get 1. Not means 1 will become 0 and 0 will become 1. These are logical operators. So next, bitwise operators. What are the different bitwise operators? So it is ampersand given there, and or, and you can see here this is double less than, and this is the cap operator, and this is double less than. You will learn detail about the bitwise operators later. And the assignment operators, equals to is assignment operator, and what is plus equals to? It will add by 1. Then if I'm giving some a value 5, if you give plus equals to, the value will be incremented some to 6. Okay, so minus equals to, it will decrease a value and then assigns, multiplies a value and then assigns, divides a value and then assigns. Okay, and this is the conditional operator. Okay, or ternary operator. Okay, so the syntax for the conditional operator is expression 1. Okay, expression 2 colon expression 3. Okay, so for this expression 1 is true means expression 2 will be evaluated. Okay, that means here the condition in expression 1 will become true, means the expression 2 is evaluated, or else the expression 3 is evaluated. That means I can simply say something like this: if a greater than b, okay, a greater than b, you perform the operation a plus b, else a minus b, right? So here, if the a value is 5 and b value is 6, so now what will be the a greater than b? Condition is false here. Here the condition is false. So for if it is false, a minus b is evaluated. If it is true, if I give a as 15, a is greater than b, the condition is true, so the expression true will be 2 will be evaluated. So this is called ternary operator or conditional operator. Okay, depending on the condition which line of statement will be executed, the compiler will decide. Okay, so next, size of operator. Special operators will be there. Size of operator. So size of operator means if you just want to know the size of a particular variable, okay, so you will use the size of operator. Okay, and later on another operator is ampersand operator. That means in the memory you are going to store some values, so you can know the address of that particular value, the address where the particular value is stored, with the help of this address operator. Okay, and the next operator is asterisk operator. So this is also, like, you can say pointer operator, like pointer operator, which about pointers you'll be learning in the later sessions. Okay, so next, special operators are done. And now, as I said, a plus b is an expression, right? This is, you call these as expressions. Okay, see here, I can give a plus b e, so sum equals to a plus b is a sum expression. And now here, like, we'll take some expression like okay, some a plus b minus c. So this is one expression, right? So what will be evaluated first when you will give this? Okay, for to make it simpler or understand very particular, I'll just give with the numerals 10 asterisk 10 minus 10. So I have given you to evaluate this particular expression. So you might be get confused which pair of tens will be done first initially. So in this expression, initially we will go with multiplying this 10 asterisk 10. So that is 100 minus 10, right? So the result will be 90, right? So here in this expression, this is a small sort of expression that we can sort out. But how the compiler knows which both expressions, which expressions will be evaluated first. So for that, we are going for the operator precedency. Operator means these are all operators, right? So precedence means priority. Which operator must be given prior importance, first importance. So we are having a operator precedence chart. In that, asterisk, I can say asterisk, division. If you compare the basic arithmetic operators, asterisk, division, in the expression asterisk and division are there, they will be executed initially, and later on this minus or plus, whatever it is, they will be executed later on. Again, this is called operator precedence. Okay, which operator must be done first and which operator must be done later. Now if my expression compromises like 10 asterisk 10 divided by 10 again, so I said both the asterisk and this divided by will be of same precedence. right? So now which operator will be evaluated first now, as these both are having higher priority. Okay, so the left hand to right hand associativity and right hand to left hand associativity will be given depending on the operators. Okay, so let us see that. Okay, see here, you are having an expression 10 plus 20 plus 30. So initially the asterisk operator is having higher priority, and these will be calculated first. Okay, and not 10 plus 20. Okay, so next, operator associativity. Associativity means which operator must be associated, like means considered first. Okay, if you are in the arithmetic operators, your asterisk and backslash, like division is having the same higher precedence. If you encounter both the operators in the same expression, so you will just give like left to right precedence. Like even you are, it is going compiling left to right, which operator will be encountering first, it will evaluate first, later on the next expression. Okay, so here you are having postfix, prefix, some different of operator precedence chart. Okay, I'll just show you operator precedence in C. Okay, see here, multiplication, division and modulus are having the higher precedence, and later on the addition and subtraction, later on bitwise shift left, bitwise shift right, all these things in detail you will be learning later. And here this bitwise will be the next preference. So if you encounter these both operators in the single line of statement, as they are having higher precedence, actually if you are having same operators in the same line of statement, you will go with the associativity. Okay, associativity of the operators. So here you can see here this operator associativity. Okay, this is the precedence which must be, this will be asterisk will be executed first, later on the 10. So after that, if you encounter the same higher precedence operators, initially from left to right it will associate. That means 100 divided by 10 will be done. Again the next operator, associative operator is asterisk. So from left to right, this division is having higher precedence and this asterisk is having lower precedence. Okay, we will see the same here. Okay, the next is storage classes. Okay, so here we'll go with the storage classes. Storage classes. Okay, so what about these storage classes? Every time I'm saying you, if you declare a variable, it is going to store somewhere in the memory, right? Surely it will store in the memory, but let us see how these things will be stored in the memory. Okay, for suppose I'm just giving, okay, you come consider this as your memory, right? So now here I can say there are different types, different parts of memory. Memory is having different, our home is having different rooms, right? We will some part of the home is called as kitchen, some part of the home is called some dining room or living room. Likewise, your like your memory is also divided into some partitions. Okay, let us see these, how these partitions will be executed. Like just a second, see here, just I'm just inserting a table here. Okay, this is a single table, in the memory only you are having. So again, what is the table? I'm not giving table, you just consider some part of this room or in the memory is nothing but a stack. Okay, where your data is stored one after another. Okay, data is stored one after another, and you will be given for sure memory address also. Okay, so if in the memory, if it is going to store one location after another location, you just call it as stack part. Okay, some room you will call kitchen, right? So here this part of the memory where like values are storing one after another. Okay, so this part is called stack memory. Okay, initially every C program going to store values here only. Okay, and some part we can say these are the registers. registers okay, so here you are having the registers. Okay, so registers. Okay, and another part of the memory will be there, and this will be your heap memory. And that means this part of the memory is just called as heap. Okay, we will call as heap memory. Okay, so your stack is there, registers are there, heap is there. Now my point is I am just declaring some integer I equals to 9. Okay, so initially every variable in the C program is going to store in the stack itself. 90%, or I can say major of the variables will store in the stack itself, right? So now when will be the registers stored, and the registers are usually given some small part of the memory itself, right? Some smart part of the registers. So when you want to access like fastly, I want to access some sort of variables quickly, so I will store those variables in the registers, because these registers like quick access will be there with the program. If you declare a variable as register, then the quick access will be there with that, with this memory location. Okay, I'll say if you are not giving anything means this is called auto. Okay, so automatic, auto. So if you declare this variable int I, it is going to store here in the stack of the memory. Okay, heap not at all we are going to touch here, but I'm just saying like heap is also one part of the memory, and stack is one part of the memory, and registers are one part of the memory, right? Now I'm going to store in the stack. So let us see, like further we will just discuss some storage classes we will be seeing. So it is automatic, external, static, and register are four different storage classes when you are declaring variables. Okay, in you have to declare any of these four. If you are declaring nothing means it is considered as the automatic storage variable. You can give the keyword as auto. Okay, so this is the automatic. Usually in general default it will be auto. Okay, if you are giving nothing, so it may be automatic, it may be external, static, and register. So not only regarding the memory, if you declare a variable, it comes to the life of that particular variable also. What is the life in sense? In the sense, if I'm just declaring here, see here, I'm declaring some, I can declare here, okay, int I equals to 9, right? So if I'm declaring another function here, okay, so some int, some x, I have given the function. Okay, so why I'm writing this new function? Okay, just wait, I'll show. It is printf some ABC. I just want to print the ABC, right? So this is another function, right? So this is nothing but modularity. I will declare n number of functions, not only x. I can declare n number of sub functions also there. Regarding functions, you can see later. Now, what I'm going to say is this is the integer value, right? So I have declared I. It is going to store in the stack. Okay, and if I'm not giving any value means it is going to store some garbage value. Garbage value means here I will give auto. So this is the first storage class here I am giving as auto. That means this lifetime of this variable will be within this block only. Okay, within the main block only the life of I will be. I'm not supposed to use this I here. Okay, if I want to declare use that I have to declare again. That means when the control come out of this loop, out of this main function, it is the your memory x, the value given for I will be deactivated, something like the life will be ended. Okay, again when control comes here, it will be activated again anyhow. Okay, so here let us see about auto. Okay, automatic variables are allocated memory automatically at the runtime. The visibility of automatic variable is limited to that block which they are defined. Here I said in this block only I have defined. Okay, I, so the life of this I will be in this block only. When the control comes out of that block, the this will be deactivated. Okay, the memory is not freed, but this is the life is no more for I. Okay, and when the control comes back again here, again the I will be, when you are using the variable again the I will be activated. Okay, the life of a I will be activated. The automatic garbage values initialized garbage value by default. If I am not initializing any value means, you go here, something here I is storing here. Okay, so what is the memory there? So 10 will be given to the I. Okay, by default if I want to print I, if I want to print I here on the output screen, suppose if it is some 100 or 10, that value will be printed. If I assign some value here, some 5 or 5, I have assigned the value here. So when I am declaring that value here, when I have given I, so I is given the value of some 505. If I am giving nothing means, in that memory place whatever the value is there, that garbage value will be assigned. Because this is because every time when you are not using the variables, the memory will not be freed, that means emptied. Whatever the value is placing there, whatever the value is there, that is going to store. Okay, so now this is the auto. So next, the memory assigned to the automatic variables gets freed upon existing the block. Okay, like whatever the memory we are assigned, that gets freed. Okay, the keyword used for defining automatic variables is auto. Okay, and next here he has shown the example here, int a. Okay, so if I am giving nothing storage class, it is just auto. So we have to give uh, like declaring variables, you have to give storage class. Okay, data type, variable name, value. Okay, this will be the syntax to declare a variable. You have to specify the storage class also. If you are giving nothing means it will be considered as auto. If you are giving registers means it will be, the values will be stored in the registers. So what happens in registers in general in the real time, major of the developers will not use registers, as it is very having less space. In very, like if they want speed access means we will store in registers, that's it. Okay, so is next we can say, so here he has given auto. Okay, this is also auto. Char b he has declared, and float c. Here he has given, he is printing all of the statements, printf. So what he is declaring here, I will give here I. Let us see some the how auto will be. Okay, here I'm just giving printf percentile d. So what is the percentile d? For giving, percentage is the access modifier, access specifier. Okay, so it gets values from the memory. Like integer values you have to give percentage d, for floating point values you have to give percentage f, for character values you have to give percentage d. Okay, percentage d comma I. Okay, I'm just sorry. Okay, here I'm just printing the values. See here, it has printed the 505 value. Now to see what is a garbage value, let us give some another variable x, simply x. Okay, let us see. I'm also changing here x. I'm just running the program. Okay, even though I have nothing assigned, it is returning 0. That means nothing is there, it returns 0. Okay, if something is there, some previous values will be there, that if it is going to store there, it will be getting those values itself. Initially there is nothing in the memory, so that's why it is just returning 0. Or else it will get some values already there in the memory. Those are called garbage values. The values which are stored previously, unwanted values, those are called garbage values. Okay, see here, garbage values means some dummy values, values of no meaning, like previously stored values will be attained. Next, static. Okay, if you want static means, so in between functions, if you want to use, I'm just declaring some int x function here. Okay, int x function here. Okay, and int y function. So I'm dividing my function into smaller units. These are nothing but functions. I'm just dividing for my convenience, for my programming convenience I'm dividing. And now the requirement, I have to use these values, like a value of x in between these functions also. So what I will do, I'll just declare this as static. Okay, so that I can use the value, for convenience we'll just give the value of sum, right? X and x will be confused, so now I'm just giving the value of sum here. Right, now static, if I declare static means I can use this. If you see here, suggestion is coming from me. Okay, suggestion is coming here, right? Sum. So that means if I declare a variable as static, internally I can use. For example, you just take, like you are going to hospitals, right? So if you are taking online admit card for Rainbow Hospital, for suppose, okay, everywhere, let us assume in any Rainbow Hospital you can use that admit card, like hospital card, right? In any one of the branches, in any of the branches you can use this card, validity card. You can use any area of Hyderabad or any area. So internally, in between functions, in between different functions, we can use that particular variable. Okay, this is what he's saying. Default initial value is, and the default value will be 0. And if you go again here, if I give auto here, that means automatic. If I give auto here, let us see, you get sum or not. You are getting the sum, but it should not. Let me check. Mm, like when you are compiling, you might get error. When you are compiling, you may get the error. Let us give here static itself. At the compilation time, we will be getting error, it seems. Default initial value, the variable is 0. The visibility of static global variable is limited to that particular file. Okay, you are not supposed to use that admit card in any other, like Ankura hospitals or any other, but it is limited to that Rainbow, different branches of Rainbow hospitals. Likewise, you can think. Okay, so this is the program in static, and here he is printing the values, and the output default value is 0. Okay, so it is printing the default value 0. So here the registers, if you declare a variable of with registers, means the register is allocated memory into the CPU registers depending upon the size of the remaining CPU. Okay, so memory is divided into parts, right? I have told earlier, your memory is some stack memory, registers, heap memory. Okay, so here we cannot dereference the register variables. Dereference means like we cannot free up those register values. Okay, and the access time of the register variables is faster than the automatic variables. That means when you give a variable as auto, when you give a variable as auto, it takes some x minutes of time. But if you give a variable as register, it may take less than x seconds of time when compared to the auto. So accessing with the registers is quite faster. Okay, so initial default value is 0. Okay, so and the register is the keyword for using the registered, and these are stored in the CPU registers. Okay, so static variables cannot be stored into registers since a variable not use more than one storage specifier of the same. So for if you give a variable as static variable, these cannot be stored in registers. Okay, here the program on registers goes like this. Okay, and the default value, it is printing the default value. If you give register, automatically the a will be assigned to 0. Okay, if you are giving auto, it will not assign anything, and the place garbage value will be getting. Okay, this is external. If you give a variable as external, means you can access that variable between multiple files. Okay, so file A, some 10 programs are there. In file B, 10 programs are there. So in file A, you are declaring a variable some n. So this n will be used in file B, file C, file D also, if you give the variable as extern. Okay, so external storage class is used to tell the compiler that the variable extern defined like external linkage in elsewhere in the program. Okay, and the variable is declared as extern, not allocated any memory, and it is only declaration and intended to specify that the variable is allocated somewhere else in the program. That means here you give external, somewhere in other files you will use. Okay, so initially they are not going to allocate any memory at the time of definition, declaration itself. Okay, something like globally means you can use that if you have given a card and you are giving that card as extern, you can give and I can use that card globally, worldwide you can use. Likewise, if you give a variable as extern, you can use that variable elsewhere in some other program between the project only. Okay, between the project, some doing my Gmail project, anywhere in the Gmail project. Just let me explain you clearly. So here let us assume that I am doing my Gmail project. Okay, so Gmail project, initially my page is some I'm doing inbox page. Okay, in the inbox page I have declared a variable A. Okay, and outbox page my friend is doing. Okay, this is outbox. So this external A will be used in the inbox page designing and the outbox page designing only, because it is related to the Gmail project. But if someone else is doing the Facebook project, he is not supposed to use this A. Okay, within this project only, in any number of pages, you can use this variable A if it is declared as extern. Okay, program for external storage. Okay, so what is the default value external storage is storing? It is a garbage value. Okay, so the next is type conversion. So type conversion means data type conversion. So you are converting one data type to another data type. Okay, so it is implicit conversion and explicit conversion. Implicit means internally it will convert, right? Internally it will convert one data type to another data type. The syntax will be the type name and the expression. Okay, you just given the which data type name you are going to convert. Okay, for suppose I have taken the integer value. Okay, here I have taken int uh, okay, int a b comma c. Okay, and I have taken float x y and z. Okay, so now if I add c equals to a plus z, what is the value you are getting? Okay, if I initialize a as 1 and some z as 1.1, okay, so what is the value of c you are getting? You will be getting the value of c as some 2.1. That means internally this value is going to convert to one data type, integer data type to some floating data type, it will convert. Okay, so this is nothing but type conversion. You are converting one data type to another data type. Okay, this was internally done by the compiler. Okay, so next, explicit typecasting. This typecasting is also user defined, like we will define like to which data type it has to convert, and this is called external typecasting. Okay, it helps us to compute expressions containing variables of different data types. Okay, the syntax is type expression. Okay, so here he has given double 1.2 and the sum, this is one of the data type double, and integer, some variable as integer. Now here I am converting my double higher data type. Double is having some 8 bytes of memory. Double occupies some 8 bytes of memory. Int occupies 4 types of memory. So I am converting higher data type to lower data type. Here double will occupy actually 8 bytes of memory, and here I am converting it into the integer. So converting higher data type to lower data type is nothing but explicit conversion. Okay, so the later topics will be discussed in the next video.